All right, let's dive into one of the most talked about technologies out there right now, machine learning. We're going to demystify it and get right to what all the buzz is really about. You ever stop and wonder how Netflix just knows what show you're going to binge next? Or, how your email inbox magically weeds out all that junk? Well, the answer to both of those, it's machine learning. Okay, so to really get what machine learning is, it helps to first look at what it's not. See, with traditional programming, a developer, sits down and writes out every single rule, step by step. If this happens, then do that. But with machine learning, we totally flip the script. We don't give the computer rules. We just give it a ton of data, and we tell it, okay, you figure out the patterns. So at its heart, that's what machine learning really is. It's a part of AI where we teach computers to learn from examples, from experience, kind of like how we learn, but without spelling out every single instruction for every little task. And you can probably guess that learning from all those examples takes a ton of data. I mean, a massive amount. In fact, for a typical project, a huge chunk of the data they collect, somewhere between 70 and 80%, is just used for that initial training phase. You can think of it like all the time a student spends hitting the books before they even sit down for the final exam. Now, just like people have different ways of learning, machines do too. We can basically break down their learning styles into three main types. So first up, we've got what's called supervised learning. The easiest way to think about this is like learning with a teacher, or maybe having an answer key for a test. The computer gets fed a huge data set where every single answer is already labeled. For example, you might give it thousands of pictures of cats, and every single one is labeled cat. And then thousands of pictures of dogs, all labeled dog. The whole point here is for the machine to figure out the connection between the example and the correct label, so that later it can make really accurate predictions on new stuff it's never seen before. This is the magic behind your spam filter, right? It's classifying emails as spam or not spam. And it's the same idea used to predict things like house prices or even help with medical diagnoses. All right, next up is unsupervised learning. And with this one, the teacher's gone. There's no answer key. The machine just gets a ton of raw, unlabeled data and is basically told, hey, go find what's interesting in here. It has to discover all the hidden structures and patterns completely on its own. And this is seriously powerful stuff. Companies use this to cluster their customers into different groups so they can do much better targeted marketing. Your bank uses it for something called anomaly detection, spotting those weird, unusual purchases that might be a red flag for fraud. And finally, we have reinforcement learning. Now, this is all about learning from trial and error, basically learning from the consequences of your actions. You have what we call an agent, which is just a fancy word for the program that's doing the learning, and it interacts with some environment. It gets rewards for doing the right thing and, well, punishments for doing the wrong thing. Over time, it learns the best possible strategy to get the most rewards. This is exactly how AI has managed to master incredibly complex games like Go. You've probably heard of AlphaGo, the program that beat the world's best human players. That's reinforcement learning. It's also a huge piece of the puzzle for self-driving cars, learning how to navigate through traffic, and for algorithms that handle automated stock trading. So we've got these really powerful ways for machines to learn. But how do we actually go from just a big pile of data to a smart program, what we call a model, that can make real-world decisions? Well, it's actually a pretty clear, structured process. It really all comes down to these 6 essential steps. First, you've got to collect the data. That's the fuel for the whole thing. Then comes a really important part. You have to clean and prepare that data, because trust me, real-world data is always messy. After that, you split your data into one set for training and another for testing. Step 4 is the main event. You actually train the model. But you're not done. Step 5 is crucial. You have to evaluate how well it actually performs on data it's never seen before. And then, finally, if all goes well, you deploy the model out into the real world. But, building a great model isn't always that simple. There are some common traps you can fall into, and it's all about finding this perfect, delicate balance. This quote here just perfectly nails the single biggest challenge, and it's something called overfitting. This is what happens when a model learns the training data too well, like it even learns all the random noise and the tiny irrelevant details. It's exactly like a student who just memorizes the answers to a practice test, but doesn't actually understand the concepts. They'll ace the practice test, but then they'll completely bomb the real exam. And that brings us to this big idea called the bias-variance trade-off. See, if your model is too simple, it underfits. It doesn't even capture the basic patterns. We'd say it has high bias. But if your model is way too complex, it overfits by learning all that noise we talked about. It has high variance. The real goal, the holy grail, is to find that sweet spot right in the middle, a model that can generalize and work well on brand new data. And trust me, getting this balance right isn't just a fun little puzzle. For some companies, it's a multi-million-dollar problem. Okay, so you're probably hearing all these terms flying around. AI, machine learning, deep learning. It can get a little confusing, right? So let's just quickly put machine learning in its proper place by looking at the AI family tree. Right at the very top, the big umbrella, we have artificial intelligence, or AI. This is the broadest concept of all. It's really any system that can mimic human intelligence to get tasks done. Now, machine learning, what we've been talking about this whole time, is a subset of AI. It's a specific way to achieve AI. It's not just any system that seems smart. It's a system that learns patterns directly from data without a human programming in every rule. And then, nestled inside machine learning is an even more specialized area called deep learning. This is the technique behind a lot of the crazy breakthroughs you've seen recently. It uses these complex, multi-layered things called neural networks, which are, well, they're loosely inspired by the structure of the human brain. Phew, we've covered a lot of ground here, so let's wrap this up. What are the big things you should walk away with? Let's just boil it down. Okay, here's what to remember. First, machine learning is all about teaching computers to learn from data. Simple as that. Second, there are those three main flavors: supervised, unsupervised, and reinforcement. And finally, just remember that good machine learning always depends on three things: good data, choosing the right model, and then evaluating it properly. Machine learning is just this huge, fascinating field, and it's moving at a wild pace. It really makes you think, not just about what computers can do, but about how we think and learn too. So thanks for diving into this with me. It leaves me wondering, what complex topic should we break down next?